Today first I go through homework 1. Yeah. So then I already give you extension for homework 2, 3 more days. Yeah. So after that, on Tuesday next week, I need to talk about homework assignment number 2, explain that. So we will have midterm on Thursday. How about that? Thursday next week. Yeah, next Thursday. And not this next Thursday. Yeah. So, yeah. Hope you have plenty of time to do preparation. Yeah, some students told me, spend most of the time on homework assignment 2, so no time prepare for the midterm. So now you have 1 more week, so hopefully you have used that whole week to prepare for your midterm. Yeah, at least. Yeah. All right. Yeah. Right. Yeah. Yeah. I'm so spring break. Yeah.
Oh, Jenny wants to be let into the room.
Oh, good. Oh, so, all right. Oh, yeah, here. Jenny. Oh, okay. Oh, sorry, I didn't see it. Yeah. Only one computer I can see. Oh, here. Yeah, I can also see it. All right. Yeah, good. Just let me know if your friends cannot join, so can text you or in any way send you a message. You can let me know. Yeah. Yeah. All right. Yeah. So, yeah. Let me see. What should I start first? Oh, yeah, let me just start with this one. Homework assignment number 2. Yeah, let me see. If I want to say something, so probably after the break time, I can say something. Just a few hints. Yeah. All right. First, your homework assignment 1, overall, it's pretty good. Yeah, because the average is 84. That's a pretty good one. Yeah. But I noticed some problems. So let me explain a few problems. Yeah. All right. Yeah. Number two, yeah. Many students pick A. Yeah. Yeah. Many students pick A. The answer is C. Yeah. And we know, A always separable. Yeah. So the question is, how can you show it always separable? Yeah. If you can show, that's good. Okay? Yeah. But here, if we use some special way we did in class, but that's not good enough. Yeah. Remember, there is a way we can factor x to the nth power out, but that way won't work. Okay? That way gives you some hope, but still not good enough. Factor this out, then you have this y over x function. Okay? Yeah. And then you can let u equals y over x. Yeah. So y equals u times x. Then y prime equals u prime plus u prime x plus u. Yeah. Product rule. Yeah. Yeah. U prime x plus u. All right. Y prime equals here y to the m fu. The question is, for any n, can you separate it? For any n, Is it possible you can separate it? right? Yeah. Yeah. So that's the right. Okay, yeah, that's the problem. Yeah. But we know for some special, if we use a different way, remember if the structure has some ax plus by to the nth, for this case, then we let u be this ax plus by. Then we can make it separable, because here u prime equals a plus by prime. So y prime equals y prime equals u prime minus a over b equals u to the nth. Now we can see it's separable, because we cannot see x, so this separable. So for this special case, it is separable. For other cases, we cannot show. So here, if we cannot show it's separable, probably some other people can show, right? Before anyone can show it is separable, we should treat it not separable, right? Yeah. So before anyone can show it is separable, we should treat it as non-separable. Yeah. Probably in future someone can show us using some very smart technique, make it separable. Yeah. All right. So that's this question. For other question, question 4 is false. Particular solution, because this one you need to look at the what's that, singular solution. Logistic, because this logistic equation is very special. Y prime equals ay time minus by squared. This is logistic equation. And in class, we solve it. We have two solutions. One solution, y equals 0. One solution, y equals 0. Y equals 0. Okay? Second solution, y equals 1 over, some c e to the, a, b, t, minus 1, approximately. I cannot memorize exactly. The structure, similar like that. Here probably a minus b. Or b minus a. Just something, close to this one. But c, that's constant, could be arbitrary constant. That's the general solution. So here you can see, for logistic equation, you need to know this fact. Special solution, general solution, right? Because c you can change, but this general solution does not contain special solution. Because 1 over something can never be 0. 1 non-zero, numerator non-zero, the bottom, it cannot be 0. Yeah, first, we do not allow it to be 0, can never be 0. All right? Yeah. So we call this case singular solution. Singular solution. Okay? Yeah. Yeah. So that's the definition of singular solution. So it is false. Any particular solution of logistic, this is a particular solution. This solution cannot be treated as a special case of the general solution. Yeah. So here, I talk about this example, so you should have this example in your mind. Okay? Yeah. Because many times, for many questions, you needed this example to help you answer the question. Okay? So this example, you should memorize it. Yeah. It's so special. Okay? So special. Yeah. Yeah. Yeah, but sometimes I may not say logistic equation. Here I said logistic equation. Sometimes I just say first order ODE. First order ODE. Okay? So this is a nonlinear ODE, first order ODE. Yeah. So I do not say linear. I just say first order ODE. Sometimes I may say autonomous ODE. Yeah, because here you only have y, no x. So we call it autonomous ODE. Yeah. So if I use a different way to call, yeah, because logistic equation is contained. Yeah. Then this example you can use it. Particular solution, you can use it to answer your questions. Yeah. All right. Yeah. So that's why this example is very important. Yeah. All right. Any Bernoulli equation can be solved by certain specific formulas. It's true, so many students pick false, yeah, because Bernoulli still, remember, we use a special substitution, then it can be solved with a specific formula. Yeah. There is a special substitution. Yeah. Then it can be solved. If we can solve, we can write the formula explicitly. Why you say false, right? So many students say false. Yeah. All right. Number 6, answer is 2. If you do decomposition, factorization, y minus 1, y plus 2, double root. Double root, but we want to have different solution, number of different solutions. So it's not 3, so 2 different solutions. Yeah. Okay? Yeah. Yeah. Still, many students missed this question. Yeah. Yeah. When I did grading, actually the first part, you can look at your paper. Most students missed more points for the first part. So the first 7, you can see how many points you missed. Because after question number 7, all computation questions. Yeah. You did quite well for computation questions. Yeah, but some students missed 2, some students missed 3. Yeah. Yeah. Concept questions. Yeah. All right. And number 7, remember this one. Number 7, this special example we did in class. Yeah. And actually, I look at your work. Yeah. Many of you did. Later I will talk about that. Yeah. Many of you did fine. Yeah. So based on the hint from the textbook, we use Z. Yeah. But many of you use that U. Yeah. Yeah. It's okay. Yeah. So many of you use, if you use the U operator, U equals Y prime. Yeah. So then by the chain rule, Y double prime equals U times U. Yeah. Yeah. So you wrote u prime, but I hope you understand this u prime as du over dy, not dx. Du over dy. Yeah. Do not get confused. Yeah. So then you can write it in this way. Yeah. Then if you put it back, so you have y, you have u prime u, right? So that's the first order for the, okay? Yeah, yeah, yeah. All right. Yeah. So, right. So this example, oh, yeah, now I can get back to your homework assignment number 2. Can you get some inspiration from this one? Remember homework assignment 2, I changed this to a more general case, y prime, y double prime, dot, 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 to nth, y nth derivative. Yeah. Then I ask you, can we reduce the order by 1? N minus 1th order. Can you get inspiration from this question? Yeah? Yeah. Here, I do not ask you to prove it. Yeah, because some students try to prove. If you want to prove, you need to be familiar with a few mathematical tools. Yeah. One, mathematical induction. So if you can do mathematical induction, one. Another, apply product rule of derivative multiple times. Product rule. Yeah, you know, you can apply product rule once, no problem. How about apply product rule n times? Right? Yeah. So if you really want to prove it, you may need to apply product rule u times v, but apply it derivative n times. Then there is a formula. Yeah. So you may need that, you know, n times there is a formula. Similar to binomial formula. Yeah. It looks similar to binomial formula, yeah, but, you know, yeah. Yeah. But here I do not ask you to prove. So here I ask you, so if you can, based on your current knowledge, you can make some good judgment. Yeah. So that's what I like to see, you know, because you have old experience. Yeah. Old experience. And another thing is, if you really want to generalize the result here, give you more confidence, you can work on n equals 3. Yeah. N equals, yeah, so one way you can try, is it possible to make this just one more, this equation as the second order ODE? Yeah. 3, you just do, you know, one more derivative, second derivative. Yeah. If you can make it second order ODE, then you have more confidence, right? Yeah. So you're along the same path, so you have more confidence. Yeah. The higher the order is, technically more involved. Yeah. But so you know, yeah, so it relies on some computation work. Yeah. Yeah. All right, so that's this question. Yeah. All right. And number 8, yeah, number 8, I swap it dx dy. Yeah. Some students didn't swap, yeah, but I didn't take points off, yeah, because it's my problem, yeah. But many students, they swap it, yeah. So when they swap it, then I can talk about a few problems. Oh, Yeah. Well, I move that. Yeah. I don't want to move it. Yeah. Yeah. All right. So for those, yeah, I will post this file after today's class. Yeah. Yeah. So some students, they didn't swap it. Yeah. Yeah, I noticed some problem. Yeah. Yeah, some students, cancel out. Yeah. So here, if we do not do the cancellation, it's exact. So then you solve it using the, exact form. You can solve it. Yeah. But some students cancel out that e to the 2x. It's okay. Yeah. Then you can use the separable. Yeah. So they use the separable way to solve it. So that's still okay. Yeah. All right. Right. Yeah. So then, yeah, let me see. Oh, yeah, one way is not right. I saw, probably only one student. Yeah, one way is not right. So that way is, so that student did this way. First, cancel out that e to the 2x. Okay? Then, this differential form. Then that student apply integration directly on the whole differential form. Then it won't be correct. Yeah. You cannot apply integration on the whole differential form because you need to consider total differential concept. So here, you need to worry about total differential concept. Yeah. So here, dx dy, because partial derivative is involved. When you do that way, you didn't consider the partial derivative structure. So that's the total differential. Yeah. So one student did that way. Not correct. Okay? Yeah. So you need to know. So don't do it. Right? Don't do it that way. So either this way or, separable way. Yeah. Two different ways. All right. Oh, then regarding the last, some students, yeah, so here implicit form is okay, but several students solve for y equals, arc, cosine, inverse, yeah, that's okay. But you do not have to write in that way, yeah, but also correct, yeah. All right. Yeah, number 9, yeah, some problem, yeah. This one I pick from the textbook. Okay, I pick from textbook. Yeah, the textbook original question, the integrating factor is given. So in the textbook, this integrating factor is given. Yeah, but if I do not tell you, you may not see it. Yeah, so some students try that R star way. Yeah, because we want to calculate it. Integrating factor, remember we have a R formula, partial P, Q, R star formula. So that way doesn't work. Okay? Yeah. Does not work. So if it does not work, yeah, then you need to find a different way. Yeah. You need to find different. Yeah. So then, some students simplify it, or use this integrating factor to, to get it to work. Yeah. So that's okay. And some student, use the, separable. Yeah. Because you can make this, separable. Yeah. Okay. Yeah. So also okay. Yeah. Yeah. So here, I just want to, sometimes when you apply some standard method, it doesn't work. Now, for this question, I like you to try different ways to solve it. Yeah. Okay? So, yeah, here, that's a special case. Yeah. All right. Yeah, number 10. Number 10, I noticed some problem. Yeah. Number 10. Yeah. Number 10, yeah. The first part, you are doing fine. Okay, yeah. So you get this function. Yeah. So then the second part, yeah. Most of you did, yeah. Not using the formula here. Here I just use the formula directly. Okay, I use the formula directly. But most of you use a product rule. Yeah, so that's probably what you learned from your ODE class. Yeah, so because in this class, after we derived, so we went through all the steps. So we finally get a formula. So usually we just apply the formula directly. But if you use the product rule, you should get the same thing. But the problem is, some students, when they apply the product rule, the computation is a little wrong. Yeah, so I saw, so different errors. Because product rule, you need to make the structure right? So, together make right. Yeah, but some students messed up. Yeah, some students messed up. Yeah. So here, what I want to say here is, yeah, two ways both okay, but you need to make sure you find a better way, avoid mistake, yeah, avoid the problem. Okay, yeah. So the product rule, several students, yeah, just miss a little bit, yeah, yeah, yeah. So that's that question, yeah, yeah. That question. Yeah, if you have plenty of time, you can find it. Yeah, because sometimes they did a variation. Yeah, so if you miss somewhere, if you do the variation, then the ODE, your solution won't satisfy the ODE, right? Yeah, yeah, but because you need to do more work. In that way, you need to do more work. Yeah. Yeah. Oh, number 11. The problem for number 11 is most of the students didn't do it this way. Most of the students, they plug in, so they take first derivative, second derivative on those two solutions, try to derive, try to find A and B. Yeah. So I saw most students did that way. And they can get the same answer. They can get the same answer. Yeah, this one. Yeah. But the main problem is a lot of computation. Yeah. A lot of computation. Yeah. 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 It takes a lot of time. Yeah. But why you do not use our characteristic equation, lambda 1, lambda 2? Yeah. We have three cases from discriminant. Yeah, yeah. Discriminant of the quadratic equation of this characteristic equation. Yeah. And the case number 3, two complex roots. This two complex roots, case number 3. Yeah. So then, based on the roots, we can write the characteristic equation explicitly. In that way, you do not need to, first derivative, second derivative, try to do some, a lot of computation to derive A and B. Yeah. So that's a better way, faster, yeah, through characteristic equation. Yeah. 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 So that's the common problem. Yeah. Only small number, relatively fewer students using this way. Yeah. Yeah. Number 12 looks fine. Yeah. Number 12 looks fine. Yeah. Number 13. Yeah. So number 13, So that reduction, order reduction. Yeah. So that technique. Yeah. Here I use the hint from the textbook. Yeah. Z. Yeah. Yeah. Many of you use the U. Yeah. Yeah. But I hope you know when you use the U prime, that means du over dy, not du over dx or dt. Yeah. So, yeah, because it's quite confusing. Yeah, quite confusing. Yeah. All right. Oh, this question, yeah, only one student did with full credit. Most of you lost 1 point because you didn't give another special solution, y equals c, z equals 0. Yeah, yeah. I remember in class I talk about that, right? Yeah. Because when you cancel, yeah, here, when you cancel out z both sides, yeah, here, yeah, because there is a z cancel out both sides. Before you cancel out z, you need to consider z equals 0 could be a solution. So you need to check it. But z equal to 0 is a solution. Yeah. So y prime equals 0, y equals c is a solution. Okay? Yeah? So you lost 1 point. If you didn't write this special solution out, yeah, 1 point. Okay? Yeah. Be careful. Yeah, next time. When you do cancellation, you cancel some variable. Yeah. If you cancel constant, it's okay. Yeah. Non-zero constant, yeah, no problem. But if you cancel some variable expression, then you need to worry about if it could be 0 or not. There is a possibility that expression could be 0. Okay. Yeah. Just, be careful. Yeah. Because sometimes, although this is a special solution, but sometimes it could be that special solution is the one you need to use. Yeah, that's possible. So you cancel out, you throw away a useful solution. That could happen. Yeah. Yeah. All right.
Would it be the case that if so if this differential equation had like a y on the denominator, would you not be able to do this substitution because then z equals 0 wouldn't be a solution?
Yeah. So y denominator. Yeah, because so here you don't, because we factor z out, that parenthesis non-zero, 0, so z equals 0 multiply a non-zero also 0. So you don't worry about that part. Okay? This z equals 0 already satisfies the whole equation. Yeah. So dy dx doesn't matter. Yeah. Because after you factor this out, there is a parenthesis. So so you consider case 1, this z equals 0. So no matter the parenthesis equals 0 or not, doesn't matter. Okay? This z equals 0 always a solution. Yeah. So you just get that solution back. After that, because you already considered that case, you can assume z non-zero. You can do the second part. Yeah. Just don't throw away something useful. Yeah.
Is that the same thing like on number 10, if you divide by x, so you have to do that same thing?
Divide x, number 10. Yeah. All right. Yeah. So, okay. Yeah. Good question. Yeah. Good question. Yeah. So, number 10, we don't worry about that. Number 10, x is a variable. Yeah. The variable, although it could be 0, it could be 0. Yeah. But we consider that form. Yeah. So we remember when we divide by, we get this, we call a standard form. the standard form. Our goal, we solve for y, so y function. Y function, okay? All right. So x is treated as a variable, yeah? So although here, here we worry about, so because in this expression, x cannot be 0. X cannot be 0. Here, x could be 0. X could be 0, okay? Yeah, all right. So there is a small difference. The small difference we will look at in the final solution. Final solution. So this is the final solution. So final solution here. Yeah. So our final solution, we go back to the original equation. Yeah. So this one, this standard form help us to get this solution. So but we will verify if it satisfies the final one. Yeah. Yeah. So here, your question. Yeah. There is a potential problem. All right. Potential problem. Yeah. Potential problem. All right. Yeah. Yeah. But here we can do still. We can keep our computation going. Yeah. Like what we are doing here. Keep doing. Yeah. All right. Yeah. So after we get a solution, then we verify it to the original question. Yeah. So then, if it is satisfied, yeah, so then we do not worry about it. Yeah.
Okay, so then basically you're saying since we're already solving for the x as the variable, you're going to get to a solution that you're going to test anyways.
Yes.
But with the z, you're doing a substitution, so then it has.
Yeah.
You're not solving for the z version. You're solving for the x version.
Right. Right. Yeah. So the z, something. Yeah. So here, we can see this way. Yeah. All right. So when we do something, yeah. So here, cancellation, division. Yeah. That question, cancellation. This question, division. Yeah. So then you need to. So there is a warning sign. Okay. When you do that, you can do it, but there is a warning sign. Okay. You need to. When you work on it, you need to keep an eye on every step you are doing. Yeah. And yeah, so how to say that? Yeah. Yeah. So here, when we do division here, the problem, yeah, let me see. Yeah. All right. Yeah. Yeah. So one thing difference here, it's a variable. All right. That z is a function. Yeah, is a function. The variable, because our goal, our solution is a function. Our solution is a function. Okay, function of this variable. Yeah. Yeah. So for this variable, the way we handle the variable is different from that function. Yeah. Function, when you do division, you throw away one possible solution. So here, this variable, we change the form. We just change the form. Okay? But when you change the form, the domain could be different. Yeah? Because here, x is not allowed to be 0. That place, x allowed to be 0. So domain could be slightly different. So the impact is you may change the domain. Yeah. All right. So in other words, the domain here for this equation could be smaller because x is not allowed. Okay? The domain could be smaller. All right. So that one, the domain is larger. Okay? Yeah. So you find a solution from this one. The domain could be smaller. Yeah. Yeah. All right. Yeah. Yeah. But they could be. So could be. So there is a possibility. But here, this function, the domain is not smaller, right? So if you kind of look at a function, we allow x to be 0, right? Yeah. Domain is not smaller. So here, there is a possibility the domain could be smaller. Smaller means removing that x equals 0 point. That's the domain. Yeah. But this one, we don't need to remove that point. We allow. Yeah. So that means this operation does not cause any problem. Does not cause any problem. Yeah. We will check it. Yep. Does not cause a problem. Yeah. 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 But yeah. But every time when you do division, you need to think about if there is some potential problem. Sometimes you have, sometimes you do not have. Yeah. Yeah. All right. Yeah. Okay. Yeah. Next, let me look at the time we have. Yeah. Yeah. Actually, for most of the there is another problem I like to talk about, some common problem. Yeah, here. Many students, before we stop at the break time, let me talk about that issue. Yeah, because many students lost a few points due to that reason. Yeah. Here we have several word problems. Yeah. I want to talk about that word problem, together. Yeah, yeah, yeah. Because most of you did quite well overall for these word problems, but this place, so many of you missed a point. Yeah, yeah. So for this one, Newton's law of cooling, many students didn't write this ODE out. So you can look at. Yeah. So we have two questions. Many students just write the solution. Yeah, because based on the Newton's law, just write a solution. Yeah. Here we have two Newton's law, right? Another is this one. Yeah. Yeah. And many students, they write solution form directly there, plug in some numbers to the calculation. Yeah. So there. For each one, if you miss the ODE from the model, Newton's law of cooling model, I took 1 point off. Yeah, I took 1 point off. Yeah. Here, let me explain it. Explain it. Yeah. All right. There are a few points I want to explain. Yeah. Yeah. First, we know modeling step to set up ODE is important. If I only allow you to skip the decay model. For decay model, because too simple, too simple. So if you do not write that ODE, you just write the function form. Yeah, I know you know it. Yeah, so that's fine. Yeah, other than the decay model, yeah, because you need to do a lot of understanding. Yeah, to set up ODE, you really need to understand, the environment of the whole question. Yeah, it's not easy. Yeah. So that ODE. Another reason I like to, take that 1 point off is I understand. Think about, here I use the psychology point of view. Psychology. Why so many students skip that ODE step? There is some reason. From psychology, because they feel not easy to set up. Yeah, I understand. They try to get around it. Yeah, because if you based on the Newton's law of cooling, it's not right. So where do you put this TA? Where do you put T0? You get confused. Yeah. So people try to get around the problem. Okay. So bypass that sticky point, okay? Try to get around it. Yeah. So using that solution form, you get around it. Okay? Yeah. So here I don't want you to bypass that ODE. Yeah. That means you feel hard in understanding. So I want you understand it. Yeah. You need to understand the, modeling step, not bypassing it. Okay? Not bypassing it. So that's why I use 1 point. So you have to do it. Yeah. Do not bypass it. Okay. Yeah. Yeah. One student sent me email asking, if she can get a point back. Yeah. Yeah. So I explain here. All right. I explain here because it's important. I don't want you to bypass it. Okay. Yeah. So you just you need to really understand the whole model. Yeah. Yeah. Because some students told me it took them a lot of time try to understand how to set up equation. Right. It's not easy. Now you want to bypass it. Yeah. So that's why I have to take some points off. Okay? Yeah. Yeah. All right, so I explained that question here. All right? Yeah. Yeah. Psychology, yeah, I know. Yeah. So when you feel something is hard, so you try to find a way to get around it. Yeah. Sometimes it's okay, sometimes it's not okay. Okay? Sometimes you get around some difficulty, yeah, it's fine. Yeah. I take it. Yeah, but here I don't want you get around it. Yeah. I want you to really understand Newton's law of cooling, how to apply Newton's law of cooling correctly. Okay? All right, so that's my explanation for this question. Yeah. So other things, yeah, so I feel, yeah, not much to talk about. Yeah, so you pretty much get correctly. Yeah. All right. The last 5 questions. Yeah. So actually, there are some common problems in the last 5 questions. One is when you apply the half-angle formula, many of you didn't simplify to the best form, the simplest form. Yeah. Some students, the answer still keeps some relatively complex root, 3 minus root 2. Okay? Yeah. So many use this way, yeah. Because they use some, half-angle formula, this one. For half-angle formula, there are several versions. Yeah, at least 3 versions. Yeah. But if you use this root version, then it's not easy to get the simplest form, because when you get this one, how do you simplify it? Do you know how to simplify it? Yeah. Can you see 3 minus root 2 equals root 2 minus 1 squared? Not easy to see, right? Yeah. It's equal, but not that obvious. Yeah. So many students did in this way. Yeah. And some students, although did the right way here, yeah, but didn't remove the root at the denominator. So we want to remove the root at the denominator. Yeah. Yeah. Although it's simple, yeah, but I like you to the best way. So I took 1 point off. Okay? For both cases, I took 1 point off. Yeah. So that's this one. And second one, I want you to write in terms of A and B, but many students still give me the, exponential form. Yeah. Many students still give me the exponential form. Although it's small problem, but you need to, follow the requirement. Yeah, many students give me this one, 72 equals essentially the same, but I like you to, just, hit the nail, right? Not some indirect way, right? Just give me the direct answer. Yeah. Yeah. Not some equivalent, indirect equivalent form. Okay? Yeah. So, although small problem, but try to do this kind of thing in a perfect way. Yeah. All right. Yeah. Number 23, yeah. A small number of students, they do not know to convert it to sixth root. Yeah. A small number of students. Yeah. Most of you know, in order to compare, you need to use the, same order root. Yeah. But some students, compare, yeah, in different, in some bad way. Yeah. Number 24, I noticed. So here, the degree of the numerator equals degree of the denominator. So a few students, they forgot to do long division. So here, so when the degree of the numerator greater or equal to the degree of the denominator, you should do long division to reduce the degree. Okay? Long division. Okay? Yeah, polynomial. Long division. Yeah. After long division, you reduce the degree of the numerator. Then you can use the partial fraction. Okay? Yeah. A few students, they didn't realize doing long division before partial fraction. They just do partial fraction directly. Okay? Then find something not quite right. Yeah? Partial fraction. Yeah? Could it make both sides, Yeah. But they skip some terms, then they can find A and B. Yeah. But remember to do long division. Yeah. All right. Before you do partial fraction. Yeah. Here, I just use my observation. Yeah. So here, because the structure I feel not too complicated, so I just try to, first pull one out. Yeah. Because do subtraction, we can get one out. Yeah. After that, yeah, so we can try to make numerator, yeah, because denominator x plus 3 squared, so numerator we want to get x plus 3. Yeah. So then we can split like that. After we get this decomposition, then it's easy to do the integral. Yeah. Yeah. So if the number is relatively easy, yeah, by observation you can see, then I do not use partial fraction. Only when the number is very messy, too complicated. If I use my eyes, I cannot see it. Then I do the partial fraction. Yeah. Because too complicated, For using simple observation, if I can see the answer, then I just do it. Yeah. So here, it's an example. Yeah. All right. Yeah, so the last one, last one, most of you doing okay. Yeah. All right. So that's the homework assignment number 1. Yeah. All right. 19. Oh, yeah. 19. 19. Which part? Yeah. So hyperbolic. So hyperbolic function comes from the integral of this one. Then we have. It's better use that hyperbolic function. Yeah. Otherwise, if you do. Right. Right. If you do not use hyperbolic, then you need to, very hard. Yes. Yeah. So here, yeah. So that means hyperbolic function sometimes is useful. Okay? Sometimes useful. So pick it up. Okay? Yeah. Other similar structure as sine, cosine. Yeah. But, yeah. So I think it's an example give you that experience. Yeah. So future. So put a hyperbolic function in your toolbox. Okay, that's something valuable in your toolbox. Good. Yeah. So that's our question. Yeah. Otherwise, very hard. Okay. Although people can do it, but very hard. Yeah. Okay. All right. Yeah. Let's take a break. Yeah. Then we start at 7:15.